The broad definition of sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. This definition is taken from the 1987 Brundtland Report, Our Common Future, but it's rooted in earlier ideas about sustainable forest management and 20th century environmental concerns. In the broad view, sustainable development hinges on understanding that the world is a system that is connected across both space and time. For example, air pollution from North America affects air quality in Asia, and the decisions made about farming 100 years ago influence agricultural practices today. Systems thinking, looking at what might happen to the physical world and the people, creatures, and resources in it over different time periods, is at the base of sustainable development. Systems thinking helps us to understand and address complex situations. It's the foundation of building science and results in the house as a system concept. Construction technology is typically focused on three pillars, or legs, of sustainable development: energy efficiency, resource efficiency, and environmental responsibility. Energy efficiency is mainly about using less energy to provide the same service, but it can also be about providing more services for the same energy input. When it comes to construction technology, energy efficiency is focused on using less energy for heating, cooling, and ventilation needs through good building envelope design that keeps the heat in, and by using highly efficient equipment to supply those loads. In some cases, heating, cooling, and ventilation systems can be integrated into one piece of equipment for the same or less energy consumption that would have been required from separate units. Resource efficiency is also about using less to provide more value. In construction technology, it mainly refers to recycled or recyclable materials and reduced amounts of waste material. Some common examples include cellulose insulation, which is made from 70 to 80% old newspapers, finger-jointed pine trim, oriented strand board, and manufactured cladding. All are made from short and small pieces of wood, wood shavings, and scrap that would have been disposed of otherwise. Engineered beams are another excellent example of resource efficiency, where many small pieces or scraps of wood, otherwise unusable, are made into a structural element that can span much wider openings than dimensional lumber. Environmental responsibility overlaps energy and resource efficiency, but it also includes reducing water usage, site impact, and waste streams that are part of a new house, recycling and reusing packaging, reducing water use by planting native species on a new site, building on infill sites as opposed to greenfield development, building on a site to minimize erosion potential. These are all part of environmental responsibility. Growing concern about the environment has prompted consumers to ask for environmentally friendly products. Some manufacturers have responded by developing new products, while others have modified existing products. When looking at innovative materials and assemblies, costs and impacts on current construction practices, as well as the following sustainable characteristics, must also be taken into consideration: environmental impact, the potential for disassembly and reuse in the future, the use of materials harvested from sustainably managed sources, the embodied energy and the embodied pollution in a product, how much energy and how much pollution has been needed or generated from the time the material was harvested or mined through the construction process and the lifespan of the house, and then on to disassembly or demolition.